Yeah, hello.
Yeah, hello.
Yeah, ready?
Yep.
Okay. I wanted to show you one more static route, which is default static route. Okay. So my router R3 is connected to an ISP. Okay. This is what you have the privilege in using USB. You can connect to the external network in the internet, on the internet. Okay. So I want to see internet have millions of routes, right? Millions of routes. I don't I don't want all this route. Okay. So what I will do, I will use a static default route. That is all network and all subnet mask. Okay. I can use that. So I will do that on R3. Okay. On a enable configure terminal. Okay. Interface you say 0 which is connected. And I give an IP like IP address 192.168.1.10, okay, which is my actually this router is connected to my home router, okay, which has the internet. Okay, so I give the IP address, I say no shut, and I'll have a default route, IP route. This is known as static default route, all zeros, okay, and the next stop is 1.1, which is my home router's IP. Okay. So show IP interface brief. Okay. Yes, there is this route. This is this network. Okay, and I have a route IP route static. So I have a default route. Okay? So I'll go on that and I'll try to ping the Google name server. I can reach it. Okay. Now 8.8 is sitting here on the internet, right? Google is on the internet, right? This is the Google DNS address. 8.8.8. So my router inside my topology can ping the router, the DNS Google outside my network. Okay. So
Okay.
the purpose of this default static route is once you don't want to, you have 50 networks. Okay, I have 15 networks. For each network you have to give a statement of IP route, right? I want to avoid that. Okay. Suppose router 2 has 50 networks. Let's say it has 50 networks. Okay. The router 1 will have to give 50 network entry in the routing table by using static route. Okay. So router 1 wants to avoid it. So what it will do, it will create a default route 0.0.0 IP route or 0.0.0 and next stop is 10.1. So for all the networks, it will reach to R3. Okay. Even those networks which are not present, for that also it will send the packet to R3. Okay. So yes, we have a scenario like we have internet connected here, right? And there are millions of routes. So I can use a default route. Okay. I can use a default route to reach the internet. Clear? Default route? Here, default route is clear.
Okay.
Okay.
But are we gonna include it in the router number 2?
No.
No.
We can use it actually. I think I close the router. We can use it, of course we can use it. But that should be, we can use it on R1 or R3, but not on R2. R2 will get confused.
Okay.
Okay. Because it has two directions, right? It has two directions. Even R3 has two directions. One pointing towards R2 and one pointing towards the ISP. Okay. So yeah, here I'll go and say the show run section IP route. Oh, there is no route. So I can use it. I didn't save my configuration, that's why this is not showing. So I can use this. Okay, that's it. I can use this route. Okay, so I figure out static, and you will see a default route star S star.
Okay. And if we do the SOAP route on router 2, what we would see?
On router 2, I have not saved the configuration, so that's the problem. So there is no static route. I forgot to save the configuration. Have to give the route. Okay, on R2 we can just give one more static route, default route. Only one pointing towards R1. Okay. Now let's see. I can do it. With, let's say with my source look at 0. It can do it. Let's have a repeat count of 100 packets.
Okay.
Okay. So both are using it towards each other. They are using, but it should be one direction, not okay, unidirectional. The static route is configured. Okay, suppose I'm on R2, I can configure the static route. Okay, either of this side pointing the R1, or I can do it here also. Okay, but not both. Okay,
Okay.
either I can have it here on this side or on this side. If I have it on both the sides, the route, what you will get a ping, okay, then you will get a dot, then you will get a ping, because it is sending both ways, Default route is pointing towards both sides, right? So it is sending both ways. So when you are pinging 1.1, it is sending the to 3 also, because there is a default route, okay, and one is sitting here, okay. So that's why you get some RTOs, okay, and some success. You'll find this, okay, and it is not a good practice. So you always have a default route pointing towards unidirectional, okay, one direction only.
Okay.
Right? Okay, so let's come to ERGRP. Okay. So what is ERGRP? I'm sending you this document, you can read it. ERGRP is an enhanced distance vector protocol. People call it hybrid, but Cisco doesn't like the word hybrid, so it calls enhanced routing protocol. Okay, distance vector protocol. It's a distance vector protocol. Remember, it's not a link state vector protocol, but it has some features of link state. Okay, it works like little bit of link state. Okay, not entirely, but yeah, link state for it. There are some features which are taken from link state vector protocol. Okay, link state protocol. ERGRP was a Cisco proprietary, but it's open standard. Okay, with some parts remain proprietary, like EIGRP stub and all. We'll be learning this now. Okay, so all this thing is like you have Cisco discovery protocol, Cisco proprietary protocol, but now it is in open standard. But some feature of EIGRP won't work on it. You can run EIGRP on Arista. Okay, you can run EIGRP on Arista. But if you want to use some proprietary stuff, you need to have a patch out for this. And that patch you have to buy it from Cisco. Okay, that iOS patch you have to buy it from Cisco because it's a proprietary of Cisco. Okay, if you want to use stuff, you have to go and purchase it. Okay,
Okay.
and EIGRP is actually a distance control protocol with some features of link state protocol. Okay, for example, it uses hello mechanism to discover neighbor and form neighborship. Okay. EIGRP uses hello on the multicast servers 224.0.0.10. Okay. Now, why use hellos on multicast? Okay. I have EIGRP router. Okay. This router is running EIGRP. I have one more router running EIGRP. Okay. The EIGRP sends hello packet on multicast address 224.0.0.10. Okay. Even this packet is also sent hello. Okay. It sends hello on 224.0.0.10. But why the protocols are using multicast address for communication? Because suppose you have a network here, okay? Let's say a router one more connected here and one more router connected here, okay? And they are using OSPF, okay? So when this hello reaches here in OSPF hello is 224.0.0.5. Okay. So OSPF sees that this is 10, so it's not my packet, it drops the packet. For that reason, they have used multicast. On a big, huge broadcast network, suppose there are multiple routers, they are running multiple protocols, so each protocol is identified by their multicast address. Okay. So 224.0.0.10 is for EIGRP. 224.0.0.5 is for OSPF. We'll see that more in OSPF. But let's say this is EIGRP. Okay. So
Okay.
now to become a EIGRP neighbor, okay, the hello has some criteria, okay, some packet in it, some flags in it, some attributes in it. Okay. These two attributes, which is the AS number, autonomous system number, okay, and key value.